Welcome back, learners, and let's continue with our lesson on multiplication and division of polynomials. So we are going to be now focusing on those application questions where you are really going to need to think about what you are doing here. Let's look at the first one there. So we are going to simplify the following expressions. The first one we have there is 100 halves, and these are being multiplied by xy squared. So remember, we are multiplying a constant with a monomial. Let's see what that has for us. So 100 halves here we know is 50. Then we are multiplying that with those variables, and because we are multiplying it with a constant, then it means that those variables will just stay the same the way they are. And that is going to be xy squared. So our final answer there is 50xy squared. Let's look at the next one. So looking at the next one there, we have 5x squared y, and this is being multiplied by 1/3 plus 2x. So we need to look out for us multiplying the integers together or the numbers together, and then we are going to be multiplying the variables together. And when we multiply the variables, we need to think of those exponent laws. So we are going to multiply 5 with 1/3. So 5 multiplied by 1/3, we know that is 5/3. And then there are no variables with the 1/3. So the variables that are with the 5 are going to remain that way. That is going to be a x squared y. Then we are adding, then that is going to be my 5 multiplied by my 2, that is 10. Then we have x squared y multiplied by x. Now because x squared and x have the same base, so that means that we are going to add the exponents because we are multiplying. So that is going to be 2 plus 1, that is going to be x cubed. And then y does not have a base that is the same as it, so it is going to stay that way. And my final answer is going to be 5/3 x squared y plus 10x cubed y. Let's look at number 3. So number 3, again, we are multiplying a constant with a binomial. So that is going to be us using that distributive property. So 2 multiplied by 1 is going to be 2, and the variables are going to stay as they are, that is xy. We are adding, then we are going to say 2 multiplied by 5, that is a 10, and that variable stays the way it is, right? Next, we have again a constant with a binomial. So we are going to start by multiplying the 7 with the -7. So be careful there of the positive and the negative numbers when we are multiplying, because remember, that determines the sign of our product. So we have 7 multiplied by a -7, that is a -49. And because we are multiplying by a constant, then that variable is going to remain the way it is. Then we are going to say a 7 multiplied by a 2. So inside the bracket we are subtracting. And what is 7 multiplied by 2? That is 14. And then that variable is going to remain the way it is. Let's look at the next one. We are now here dividing a monomial with a constant. Now when we are dividing a monomial with a constant, remember, we are just going to divide the numbers and then leave the variable as it is. So we are going to say 40 divided by 4, and that gives us a 10. And that variable is going to remain the way it is. What about when we are dividing a binomial with a non-constant monomial? Now remember, that denominator or that divisor belongs to each term in the numerator. So we need to be very careful of that. This means that we are going to now split them so that each term has its own divisor. So that is going to be 27y cubed divided by a -9y. And we are adding, we are going to add there with a 54y squared, and we are dividing this by a negative 9y. So what answer does this give us? We have there 27 divided by a negative 9. The answer there is a negative 3. And then we have y cubed divided by y. Now remember, if the bases are the same and we are dividing, then it means that we are going to subtract the exponents. So we are going to say it's y, and then that 3 minus the 1, that is going to give us a 2. So the answer there for the first term there is a negative 3y squared. Then we are adding, and when we add, we now are going to divide 54, and we are going to divide it by a negative 9. So the 54 is positive and the 9 is negative. So we know that is going to give us a negative answer. So 54 divided by 9, that is a 6. And then we have the variables that have the same base. So if they have the same base, this means that we must subtract the exponents. So we are going to say they're 2 minus 1, and that is going to give us just a 1. And that is what we have there. But again, we have to simplify this further, because as we are looking there, we are adding a negative number. And when we add a negative number, then we must change that to a subtraction. So I have there a negative 3y squared, and because we are adding a negative number, that is going to be a minus 6y. Right. Let's move on to the next one. We have there a constant, which is 10, multiplied by a trinomial, which is 12z cubed minus 7z minus 8. So how are we going to work through that one? We are going to again use the distributive property. Take each of the numbers of the trinomial and we are going to multiply them with the constant that is outside of the bracket. So that is going to be 10 multiplied by 12. 10 multiplied by 12 is 120, and the variable will remain that way because we are multiplying with a constant. So 120z cubed minus, then it's going to say 10 multiplied by 7. That is 70, and the variable remains as it is. And then we are going to say a 10 multiplied by 8. Now we are subtracting in there. What is 10 multiplied by 8? That is our 80. And that is our final answer. 120z cubed minus 70z minus 80. Let's look at the next one. Again, we have a trinomial, but this time the trinomial is being divided by a non-constant monomial. So again, we are going to separate them so that each of the terms in the trinomial get their own divisor. So we have 30m cubed n squared divided by 5m. Then minus 10m squared divided by 5m. Plus 60 divided by 5m. Now, divide the numbers, then apply exponent laws with the variables. So that is going to be 30 divided by 5, that is 6. And then we look at the m's. We have an exponent 3, we have an exponent 1. 3 minus 1, that is 2. And then when we are looking at the n and we are seeing if it has the same base, it doesn't have, so that's going to be just n squared, as it's going to remain the same. Then we have 10 divided by 5, that is 2. And when we look at the m's or the variables, they do have the same base, so we are going to subtract the exponents. 2 minus 1 is 1. Then we have a 60 divided by 5, that is a 12. And because the m is a denominator, we will keep it as a denominator. Let's look at the last two. So now we have a non-constant monomial and it's multiplying with a trinomial. So let's distribute it. Distributive property. That is 5 multiplied by 1, that is 5. And then we have q squared multiplied by q cubed. and that is going to be q exponent 5. Why? Because the same base, we have added the exponents. Then we are subtracting. 5 multiplied by 3 is 15. Then p multiplied by q. Because there are none that have the same base, we are just going to write them as they are, and that is pq squared. And then we have, so we are adding here, we have the 5 multiplied by the 4, that is a 20, and then there are no variables there, so it will remain 20q squared. Then the last one there, we have 45q exponent 4 minus 18q squared plus 99q. So we have 45q exponent 4 divided by 9q minus 18q squared divided by 9q plus 99q divided by 9q. So when we simplify that, what is 45 divided by 9? That is going to be a 5. And then 4 minus 1 with the exponents for the variables because they're the same base and we are dividing. So 4 minus 1, that is 3. Minus, then we have 18q squared divided by 9q. So 18 divided by 9 is 2. And when we look at the variables, we have 2 minus 1, and that is just the q. Then we are adding, we have 99 divided by 9, that is 11. And then we have q divided by q, they are the same, they become 1. So this is my final answer, 5q cubed minus 2q plus 11. Let's quickly go to an ad break, and then we'll see you just now.